Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why mastering a new language, especially the pronunciation part, feels so much harder than they make it look in the movies? Well, this new study might have a clue buried in how our brains control our voices. We all know that most people who learn a second language as adults never quite sound like native speakers, right? It is that little something we call a foreign accent. For a long time, scientists thought this was mostly because our brains get wired to hear sounds in our first language. So, when we hear new sounds in a second language, our first language brain kind of messes with our perception, making it hard to produce them perfectly. But what if it is not just about hearing the sounds differently? What if it is also about making the sounds differently? That is the big question this study tackles. You see, when we produce speech, our brain sends signals to our mouth, tongue, and throat muscles to make very precise movements. This is like learning to ride a bike. You develop motor plans. For a long time, research has focused on how our first language, our L1, might interfere with the sound perception of a second language, our L2. But this paper asks, what if there is a limit on how flexible these speech motor plans are when we're speaking our second language? This is super important because it could explain why even after years of practice, that foreign accent can stick around. So how do you even study something like speech motor plans and how they adapt? The researchers used a really cool trick. They had people speak sentences, and while they were speaking, they subtly changed the sound of their voice in real time, specifically altering vowel sounds. Imagine you are trying to say bat, but the sound you hear back is slightly more like bet. Your brain, without you even really thinking about it, will try to adjust your voice to counteract that change. This is called sensorimotor adaptation. It means your motor system is learning to compensate for the altered sound feedback. The researchers worked with bilingual individuals who grew up speaking English as their first language and learned French as their second. They had them speak sentences in both English and French. Here is the clever part: when they spoke English, the sound alteration was one way, and when they spoke French, the alteration was the exact opposite, but the same strength. The idea was to get their brains to create two completely separate languages. Specific motor plans, if they adapted well, it meant their motor system could learn distinct ways of producing sounds for each language. After they had them produce sentences with these altered sounds for a while, they wanted to see how well these new, learned motor adjustments would work in slightly different situations. They called this a transfer task. They gave participants new linguistic contexts like parts of sentences or even strings of words and had them speak these without any altered sound feedback. The big question was, would the motor adjustments learned in the full sentences transfer over to these new contexts? And importantly, would this transfer be the same for English, their first language, and French, their second language? Let's look at what they found first. Both their English and French speech motor plans adapted really well. This means their brains could learn language-specific ways to produce sounds. When they spoke English with the altered feedback, their voices changed in a specific way to compensate. And when they spoke French with the opposite alteration, their voices changed in the opposite way. This showed they were building distinct motor memories for each language, which is pretty neat on its own. But here is where the real story unfolds. When they moved to the transfer tasks, things got interesting. In English, their first language, the motor adaptations transferred really well, meaning the adjustments they learned for full sentences worked almost perfectly for the new sentence fragments. It was like the motor plan was flexible and easily applied to a situation. However, in French, their second language, the transfer was much weaker. The motor plan they learned for French sentences didn't carry over as effectively to the French sentence fragments. It was like the L2 motor plan was much more stuck in the specific context where it was learned. This drop in transfer in L2 wasn't because they forgot the adaptation. The study showed that when they went back to producing full sentences after the transfer task, they still had the L2 adaptation. This is an after effect that shows they had learned something, but they just couldn't apply it as broadly to new situations in their second language. The researchers also looked at what happened with reverse part sentences and word strings, which messed up the usual sentence structure even more. The pattern held L1 transfer was stronger than L2 transfer. So, what does this all mean? It suggests that while we can learn new ways to produce speech sounds in our second language, the motor commands for those sounds might be less flexible than those for our first language. It's like our L1 motor plans have a broad set of instructions they can adapt to different scenarios. But our L2 motor plans are more rigid, mostly sticking to the exact way they were learned. This limited generalization, this poor transfer of motor plans to new linguistic contexts, could be a significant reason why that foreign accent persists, even with a lot of practice. It's not just about hearing the wrong sounds. It's about your motor system not being as adaptable in your L2. This is a really important finding because it challenges some of the existing ideas about why L2 accents are so persistent. As we mentioned earlier, many theories focus on how our first language's sound system warps our perception of the second language. But this study provides strong evidence for a motor constraint. The adaptations were equal in magnitude between languages, meaning the learning itself was similar. The difference emerged when they tried to apply that learning to new contexts. The issue wasn't with learning the adaptation, it was with generalizing it. Now, it is worth noting that broad generalization of motor learning isn't always easy, even in our first language. However, the researchers point out that in more naturalistic speech contexts, and when things like sentence structure and rhythm are involved, generalization can be quite broad in L1. They suggest that some aspects of speech, like prosody, which is the rhythm and intonation of speech, might be key players in how well our motor plans transfer. Why this mechanism might be less effective in L2 speech is still an open question and a great area for future research. Of course, no study is perfect. This research was done with a specific group of English-French bilinguals in Canada. It would be fascinating to see if these results hold true for other language pairs and in different cultural contexts. Also, the participants were reading sentences, which is a bit different from talking spontaneously. It's possible that spontaneous speech, with all its messiness and variations, might behave differently. So, while this is a significant step, more research is needed to fully understand these motor constraints. So, to wrap it up, this study suggests that part of the reason for a foreign accent might be that our second language speech motor plans are less flexible. They're more tightly bound to the specific situations in which we learn them, making them harder to apply to new words, phrases, or even different ways of saying things. It's a fascinating insight into the complex relationship between our brains, our bodies, and the languages we speak. It highlights that becoming truly fluent in a new language involves not just mastering new sounds and words, but also training our motor systems to be more adaptable. What do you all think about this? Does this resonate with your own experiences learning languages? Let me know in the comments below. And if you enjoyed this dive into the science of language, please give this video a thumbs up, share it with your friends. And don't forget to subscribe to RUBIN'S Mind Lab for more fascinating insights into how our minds work. Thanks for watching, and we'll see you in the next one.